So let's go for some of the questions which are expected and important questions from the topics of the alcohols, phenols and the ethers. Question 1 is MPV reduction is given by. So in the MPV reduction we are going to prepare the alcohols, right? So which compounds are giving? So the options are given: aldehydes and ketones, both aldehydes and ketones. The option D is carboxylic acids. Carboxylic acids also can be reduced by lithium aluminum hydride, but MPV reduction is a selective reduction using the aluminum isopropoxide in the presence of acetone or a alcohol solvent. So it is a reduction of aldehydes into the 1 degree alcohols and a reduction of ketones into the 2 degree alcohols. So specifically the answer goes to the, therefore, both aldehydes and the ketones. Answer goes to the C. So this MPV reduction is any carbonyl compound, whether it is aldehyde or ketone, is reduced with an alcohol. An alcohol is chosen as a scapegoat actually, and when it is treated with the aluminum isopropoxide, taken thrice aluminum. This is the unique reagent, may be having its own properties, but when this aluminum isopropoxide used and with a suitable solvent, so we are taking this R1 R2 containing aldehyde is converted into the R1 R2 containing alcohol, and this R2 R3 R4 alcohol is the one which is used as a scapegoat here, that is consumed. So the reaction will be benefitable when R1 R2 carbonyl compound is when you convert into this particular alcohol, the cost of this alcohol should be very high, then the success of the reaction will be there. However, what happens to this particular the R3 R4 alcohol that converted into a carbonyl compound? R3 R4 compound is converted to alcohol. In fact, if you are really interested in the ketone preparation, if I start from alcohol to aldehyde, this is called open-air oxidation. So MPV reduction stands for what? Meerwein-Pondorf Verily oxidation, Verily reduction. It's a reduction reaction. While this compound is undergoing reduction, simultaneously the other compound is undergoing oxidation. So MPV and open-air oxidation, they are not agonist reactions. Both travel simultaneously. When reduction is taking place, the other compound is undergoing oxidation. However, it depends on what alcohol you are preparing. If it is costly alcohol is used, you use a cheap alcohol as a scapegoat, and that is converted into their corresponding compound. If these two are smaller members, let us say in the MPV reduction, the alcohol, if it is isopropyl alcohol, you get acetone as a product. These two, if it is low boiling point, when you heat it can be removed, cost will be less, it will be exchanged with the reagent also, that is another concept. Therefore, always choose this alcohol as isopropyl alcohol. In the MPV reduction, the alcohol chosen as a side product, that is the compound, should be an isopropyl alcohol. This any carbonyl compound gives corresponding alcohol. Aldehydes gives a primary, and ketones will give the 2 degree alcohol. So answer is the C therefore. So let's go to the second question. In the reaction given, an ester is given actually, a methyl group containing an alcohol is tertiary butyl alcohol, acid is acetic acid, right? So this particular ester is treated with the sodium in presence of the ethyl alcohol, converted into X and Y. X and Y are respectively. It is a reduction actually. and both are giving to the alcohols. Both are giving into the alcohols, 1 degree and the 3 degree, and 1 degree and the other one becoming alkene, and this is a third option is alkene and the alcohol, and this is a alkene and the tertiary butyl alcohol. It is a reduction actually, an ester with the sodium alcohol. It is specifically called a Bobbialt reduction. In this reduction, sodium alcohol reacts and a nascent hydrogen will come. So that nascent hydrogen will reduce here, and alcohol may be taken. This reacts, you will get a nascent hydrogen and gives the alkoxide formation. This nascent hydrogen will reduce this one and gives into the alcohol and the alcohol. So ethanol is formed, one product. Tertiary butyl is also converted into the alcohol. So therefore option goes to the A is the right answer. It's a specific name reaction rarely mentioned in some books as a Bobbialt reduction or Bobbialt-Blanc reduction. Okay, next question, go to the third question. In this question, an epoxide, that is a propene epoxide treated with RMGX in presence of acidic medium with water, that is hydrolysis in the acid means acidic hydrolysis, and X is formed. We have a wonderful concept here actually. An alkene containing this type of epoxide, when you hydrolyze it without adding the RMGX, if you hydrolyze it actually, in presence of the proton will go into protonate, and this old O may go that side or may go this side. If there, because there is a carbon, this is a 2 degree carbon. If I cut here, what happens? The O, old O go to the primary and middle carbon will become 2 degree. If I cut here, the 1 degree will become carbocation. So strictly speaking, in acidic medium what happens means it cuts here and you will get a 2 degree carbocation, and the O will become OH minus. That is after the protonation. Protonation means what? On the epoxide, a proton is added and then undergoes cut here, so that 2 degree carbocation is preferable. For example, in the consequently, if you add a water having a O18, the new OH comes in the center. Old O goes here. This is a very good point, several times asked. But however, it is an RMGX we are adding. Methyl magnesium halide is added. The methyl is a minus. So the first attacking species is not H plus here. Clearly that number 1 is RMGX, followed by the water hydrolysis in presence of the acidic medium. So R minus is attacking. So R minus has got a chance of attacking that side, this side. This side carbon has got 2 plus I effects and 1 minus effect. This has got 1 minus I and 1 plus I. So naturally this carbon will be more electron dense. So therefore methyl goes on to the terminal carbon, leaving this O to this carbon. So finally what happens is the newly added methyl goes to the terminal and the old O goes to the middle. That is 2-butanol will be the right answer. So therefore option B is the answer. But as I said, if it is a normal hydrolysis in acidic medium, the middle carbocation comes and the new H2O. If this is subsequently treated with the water containing a 18, the O18 comes into the center. Old OH go to the terminal. Similar the case, if basic medium is added, base will go to the terminal carbon and the old O comes here and new goes here. It's a similar type that a methyl prefers to add here because this is electron rich one, this is electron less. So therefore minus goes to the where electron less. So therefore terminal carbon the methyl will be occupying. So here also there is a good discrimination is there, but the answer is B, that is 2-butanol will be the right answer. So let's go for the fourth question. The question is, there is a cyclohexane containing one side methyl, one side OH. Both are shown with the dark lines. That means both are same side. That too specifically you have to take it grant that the both are towards me. If the plane is on the board, that the hexane actually will have a chair form and the board form, leave that. But taken grant that the benzene is a plane and the two groups, that is CH3 and OH, are towards you. Okay, right. With reference to the specifically methyl, the OH is towards me. On that reaction, the TCCl is added. What is the TCCl? TCCl is called tosyl chloride. It is known as tosyl chloride. So it is a cyclohexane containing the OH with a beta type, and also methyl is also a beta type. And this was treated with what? Tosyl chloride. Actually, the OH, if you want to replace, there are very few reagents are there. If it is halogen is there, huge number of bases which are stronger bases can replace the Cl. But the OH replacement is not that Cl. A tosyl chloride followed by the pyridine. In presence of pyridine we are using, that is the reagent. And then followed by what? After replacing the tosyl, we have a reagent called what? A dye, that is ethyl containing ethyl sodium salt of thioethanol. Okay, thioethanol, sodium salt of, just like a ethoxide, you can say sulfoxide is there. Okay, this is a sulfur anion is there. This is going to replace the OH. Directly it cannot, but once this group becomes into tosyl Cl, so probably this reaction leads to give the, let us say, TSCl. And then when it is substituted, what happens? The reaction passes to SN2 type of mechanism. That means if a dextro compound is taken, you will get levo compound. If the levo is taken, it will become dextro. So therefore, if the group OH is this side, in the answer the group should be that side with reference to the methyl. Why methyl is given means only for the reference. With reference to the methyl. If methyl is that side, then the reference, with reference that you have to answer. So therefore here, so with reference to the methyl this side, what are the groups? That SCH3. So methyl should be this side, S and ethyl should be that side. So answer B is the right answer. In the answer B, what is the answer given? So a benzene, methyl is this side only, but the substituted group S with the ethyl is that side. That side means what? An alpha bond is chosen. So therefore, this is a 100% inversion taking place type of the reaction, in which the sulfur is group is entered from the other side, so that the reaction is undergone a Walden inversion. So answer is B therefore. So let's go for the fifth question. In this question, a cyclohexane containing a CH2OH treated with the constant sulfuric acid, probably heating is also must be there, and then this undergoes a dehydration process here. First protonation takes place, a CH2OH is there. This CH2OH reacts with the H plus in presence of sulfuric acid, that is the catalyst here. This H plus from the sulfuric acid is going to attack on this one, followed by a loss of water is observed, and subsequently what comes as an intermediate means a CH2 plus will be formed on the carbon. Many times what happens, it cuts and this group jumps and you will get a ring expansion. But if you find there is no ring expansion, answer is there. So therefore, that is not the reaction. In such a case, what you can do is one of the H may be shifted to there. One of the H may be shifted to there. Directly, if H is deleted, you will get the answer this way. If this H is deleted, electrons are given this one. If H minus is shifted, then you will get another intermediate. Intermediate 1 changes to another intermediate. The intermediate, that carbocation comes to the junction carbon. At this time, if the hydrogen is removed from here, again you will get back. Otherwise, the ring may eliminate the one of the hydrogen from the side chain, obeying the Sedgwick rule. In the Sedgwick rule, the more the the alkyl substituted or more hyperconjugable one will be the answer. So therefore answer may be the cyclohexene containing a methyl inside cyclo, that is double bond, and outside methyl will be there, that will be the answer. So therefore answer B is the right answer, that is cyclohexene with the methyl, which is the right answer. Many times the question framed in a slightly different, I think the question is several times asked, maybe that's why this question is framed. This question, if it is asked for the same subsequent reaction, a protonation takes place, right, and then water is lost, we get a carbocation, ring expansion takes place, after that an intermediate formed like this, a 6-membered ring is formed, a carbocation and the removal of a proton. So finally what comes is cyclohexene will be the answer. This is the normal type of the several types of the examples already have come in different examinations, but in this case particularly see the answers, there is no ring expansion answer. So therefore you have to adjust it within that. Without ring expansion, this is the best answer, therefore answer goes to the B. So let's go to the question number 6. An ethyl alcohol is treated with the acetone, acetic acid. Ethyl alcohol treated with the acetic acid in presence of acid. The product is an ester and then a water. Okay. So ethyl alcohol with the acetic acid, ethyl acetate is formed. An ethyl alcohol is treated with an ester of the acetic acid. Now the reaction is the H from this side, OH can be from that side. This is, let us say, first type of mechanism, or it can also be like this also. Okay, this is the best way of representation of the two types of dehydrations can take place in presence of the acid. Finally what comes is a ester is inevitable, that is an ethyl containing ester with the carboxylic acid ethyl ethanoate or ethyl ethanoate or ethyl acetate, water is deleted. Now the question is, as a matter of fact, the carboxylic acid donating the proton is more justified. Carboxylic acid donates the proton, alcohols donates OH is the more reasonable type of the thinking. But we have an argumentation that whenever the 3-degree alcohols are participated, if the alcohol is 3-degree, if it loses a OH, what comes? A 3-degree carbocation comes, right? So this favors for the second type of the mechanism. So 3-degree alcohols loses the OH and makes the 3-degree carbocation, and that is involved in the reaction. Whereas the 1-degree alcohols will undergo, the alcohol will give the proton and the acid will give the OH, that is the rare type of mechanism. But this is a fact you have to remember through the concept. Whenever the 3-degree alcohol is there, OH from the alcohol is removed. So the statements you see in the above reaction, this is an alcohol is taken a 1-degree alcohol. So therefore 1-degree alcohol will lose the hydrogen. So that is the right answer. Breaking of OH and breaking of OH both are wrong. Breaking of CO and breaking of CO both are wrong. In the third case, one is OH breaking, one is CO breaking. So this may be the right one here. Breaking of OH of alcohol and breaking of CO of the acid is the right. And breaking of the OH from the this one is only the tertiary case, as I said, it is possible from the acid OH coming, okay, but tertiary loses the OH, so therefore answer D is wrong, answer C is the right answer. So answer C says what? Breaking of the OH, breaking of the H from the that is OH from the alcohol, breaking of CO from the acid is the right one. So therefore answer C is the right answer. So let's go to the question number 7. Which of the following compounds will form ester with alcohol? So any alcohols generally on reaction with the acids will give the esters. We have a one certain saying also, the alcohols react with the lower acids will give the us acids, and the higher acids, stronger acids, they will give the ic acids. Let us say sodium hydroxide reacting with the nitrous acid, salt formed is nitrous acid. The same sodium hydroxide with nitric acid, salt formed is sodium nitrate. 8 E's are formed in the, that is nothing but the esters. So here the ester is a mixed type. Alcohol, I am taking a carboxyl, that is a organic alcohol. Acids are chosen here, the nitric acid, sulfuric acid and the phosphoric acid. All these acids definitely react with alcohol, gives the corresponding nitrates and ates, that is sulfuric acid, corresponding ates are formed. So all this will give the esters, but they are not the organic esters. Part is alcohol is let us say nitric acid and alcohol I will show. An alcohol reacting with the nitric acid. Nitric acid is what? A OH and double bond O and a O. So this OH and that OH reacting. Here also you can have again the problem whether the alcohol donating the H or the nitric acid donating OH, or nitric acid donates the H and the OH donates, is also a debatable. Depend on the structure of the R, that is alcohol, not on the acid. So once again but somehow what happens, net is a water molecule is lost and you will get an ester of that, RO, N double bond O. It is a ic acid. Therefore the salts formed as nitrates, ATE. So this is called a alkyl nitrate. Alkyl nitrate is definitely an ester, but it is not an ester of 2 carboxylic acid and alcohol. Both are organic, isn't it? So ester is a purely organic. But here part is organic, part is a mineral acid. This nitric acid, sulfuric acid, phosphoric acid are called mineral acids. So one mineral acid, one alcohol gives the esters corresponding. Ic acids we are using, therefore ates are formed. Alkyl nitrate, alkyl sulfate, alkyl phosphate, corresponding type of the esters are formed. So answer D is the right answer. So let's go for the 8th question. The question is a little long, but an unknown compound A having molecular formula C6H12O6 on acetylation gives acetylated product whose molecular weight is 390. So let's go for the question number 8. In this question, an unknown compound A is treated with acetylation. Acetylation he is doing. In the acetylation, what happens? All the OH groups becomes into acetylated. Okay, he didn't said it is how many OH groups also, but you can guess that hydroxy groups becomes into acetylated. Even carboxylic acids, if it is acetylated also, you can get anhydride, but anhydride formation generally will not take place. So let us assume each OH takes up a OCOCH3. What extra means that COCH3 is 43 actually, but the hydrogen is going, therefore every OH, if it becomes into acetylated, 42 the AMU units will be increased. So 180 increased to 390. So 390 minus 180 means 210 is increased. That 210 is increased by every group 42. So how many groups increased means 210 by 42, 5. So therefore 5 OHs must be there. In the glucose and fructose, both will have the 5 hydroxy groups. Maybe it's glucose or fructose, but what is B is not asking, what is A is also not asking. Must be how many OHs, it's only asked. So answer is 5 OHs are there. So answer goes to the answer B is the right answer. Answer B is the right answer. So let's go for the question number 9. The question is, which of the following reagents is used for the determination of number of hydroxyl groups in a given compound? For example, if a glycerol is there, which has got the 3 OHs, right? Ethylene glycol will have 2 OHs. Methanol will have only 1 OH. Examine if this glycerol is there, you treat it with a dimethyl sulfate. Dimethyl sulfate. Then what happens? All these hydrogens get the methylated. OCH3, OCH3 and so on. The dimethyl sulfate can make ether formation on the hydroxy. If acid is there, it will become ester. So what is happening? The OH is becoming OCH3. That means for every OH, one CH3 means 15 units are increased, but removing the hydrogen. So therefore a gain of 14 units. A gain of 14 units. Let us say you take the molecular weight of this compound, if the weight is increased by 14, you say 1 OH is there. If weight is increased by 214 units, that is 28, then say 2 OHs and so on. But what group you are introducing? If it is an acetylation, you will get a OCOCH3. That is just now we have seen 42 units will be increased in the acetylation. Even the third one, C option also, acetyl chloride also reacts and you will get a OCOCH3. OCOCH3 means that is a 43 units but 1 hydrogen less, therefore 42 units increased. That increased units difference in the molecular weight divided by that you will get the how many OHs are turn up into this type of the derivative groups. So thereby we can decide the group. So all these reagents, that is dimethyl sulfate methylation reaction, acetic anhydride acetylation reaction, acetyl chloride acetylation reaction, all these three are useful. Therefore answer goes to the D. All can be used. Let's go to the 10th problem. The problem says an unknown compound A with the C8H10O3. Compound A has a formula C10H8O3. You can calculate its molecular formula 12 into 8 and the hydrogen will be 10. Oxygen will be 3. Oxygen will be C8H10O, whose molecular formula will be 154. Right? So this compound we have taken and acetylated. Acetylated means what happening? You are introducing a COCH3. You are introducing a COCH3 in the place of either OH or COOH. This H will go and the COCH3 is going to come. This may have a acidic groups or the hydroxy groups, or it may be in a alcoholic groups and phenolic groups also. We don't know what type of groups are there, but these groups are going to be acetylated and the product is formed, and the product the derivative, acetyl derivative of the first E conducted the acetylated and the product is having a molecular formula. Some product is formed whose molecular formula is telling 280. That means 154 has become into 280 means how much increase is done in this process? The increase is 126. That means the OH or this one, the H removal and the COCH3 increase means it is a 42 units gain. So how many the hydrogens are replaced means divided by 42 means 3. That means the total of these groups will be 3 groups are present. Out of these 3 groups, how many are phenolic or how many are acidic? We are going to see. The treatment of diazomethane gives methyl ester. The same compound treated with the diazomethane is nothing but a CH2N2 is a gaseous compound which converts the carboxylic acids as well as the phenols. But let us say it is a phenolic group because there is no much so many other OHs are not there. So therefore 3 OHs reacted means must be phenolic and only alcoholic, no the acidic group. So now the CH3CONH2 also gives another product whose molecular weight he mentioned already, it is 280. So that means here the 184 is becoming into the, as mentioned is 182, not the 280. Second product by diazomethane reaction, the product formed is 182. This 182 increase you calculate, 154 is becoming 182 means just a difference of 28 atomic units is increased. So with this 28 units can be expected that if the OH becomes into OCH3, That means the H is replaced by the CH3, means only CH2, that is 14 AMU units are increased. So how many 14 AMU units means only 2. So therefore here the alcoholic units are 2, total units are 3. Total units are 3, and this OH, that is the phenolic OH. A phenol containing the OHs is phenolic OHs. A phenolic OHs are 2, and there is one, the alcoholic OH, that is a total OHs are 3 and phenolic OHs are 2. So the ratio he is asking, the final answer is the alcoholic, that is hydroxyls, the phenolic hydroxyls and the alcoholic hydroxyls. Phenolic versus the alcoholics ratio finally is asking 1 and 3, 3 and 1, 2 and 1, 1 and 2. So the answer is 2 is the one type, the other one is the other type. That is the, he says that is the first one is what? The phenolic hydroxyls. Second one is alcoholic hydroxyls. So the compound must be a phenol directly attached to 2 OHs are there, and the other OHs is maybe some carbons are there, afterwards some OH may be there. This type of the compound must be there. 2 OHs are directly linked, that's why they are called phenolic. One hydroxy group is linked to the carbon, that is further linked to the benzene, so therefore they are called hydroxyl type. 2 and 1 is the right answer, so answer goes to the 2 therefore. So which of the following alcohols will be oxidized by the bromine and the KOH? So in basic medium bromine is used. The bromine is a sort of a haloform reaction must be. If the 2 degree alcohols are oxidized, consequently what happens? You will get a ketone, methyl ketone is formed. Afterwards it will undergoes the haloform reaction subsequently. So the question 1, that is option 1 is methanol. So that cannot undergo this type of the oxidation followed by the haloform reaction, and only the B undergoes a reaction wherein we have a cyclopropyl group attached to the 2 degree alcohol with the CH3, which on bromine and the KOH gives a oxidation reaction takes place, and you will get a ketone, right? The ketone with the methyl, that too. All the methyls are hyperconjugable, and then subsequently it undergoes the halogenation and then undergoes the oxidation. So therefore this type of compound will be the right answer. So therefore answer B is the right answer. Finally this will become tribromo and cuts, and you will get a CHBr3 is the bromoform will be formed in this reaction. So let's go to the 12th question. The question is, arrange the stability of the given diols in decreasing order. In general what happens? A carbon attached with 2 OHs, quite a number of elements will have, like for example sulfuric acid has a 2 S double bond O's and 2 SOHs. The 2 OHs are quite stable. But in the carbon what happens when 2 OHs are there, the electrons will come here and this totally goes out as a OH minus and H plus. So this will become H plus and this will become OH minus. Finally what happens? A carbonyl group will be formed. In general 1,1 diols are unstable. But in the case of the first case, you say there is a 3-membered ring containing the OHs, right? This 3-membered ring, what happens? The original angle actually 109 degrees 28 minutes because it is tetrahedral carbon. So the lone pair of this that is a hybrid orbital will be like this, and here also the hybrid orbitals will be like this. On the line electron cloud will be less. So therefore the overlap will not be end to end rather than the overlapping the outside. So therefore some unoverlapped electron density will be there in the cyclopropyl ring. That electron and the lone pair on the oxygen will have a resonance stability. So therefore both the OHs will have the binding capacity with this one. It also can be explained that whenever these unpaired electrons are there, the carbon will have a more electron withdrawing capacity. So therefore that is electronegativity of the carbon of this type will be more than the electron negativity of the carbon where it is a 4-membered ring with diols. So the electronegativity of the carbon 1, carbon 2 and the electronegativity of the carbon, that is 6-membered, 5-membered, if you go on see. All the carbons are no doubt sp3 hybridized, but the carbon 3, carbon 1, carbon 2, if you see, electronegativities are decreasing. What is that electronegativity? Means electron holding capacity here. So therefore it is the unpaired electrons are there, therefore it pulls this one. So the pulling character are showing this through the mesomeric effect. It will have a double bond character and it will have a holds the OH, that character we are saying electronegativity character. So therefore as we are going from the 3-membered to 4-membered to 5-membered, holding capacity decreases, therefore the compound 1 will be the more stable than the 2 than the 3, therefore order D, that is 1, 2, 3 is the right answer. Question number 13. In the reaction sequence, the butane is treated with selenium dioxide followed by the lithium aluminum hydride. So the compound is a butane. A reagent is selenium dioxide. Selenium dioxide has 2-3 specific types of the reactions. One of the reaction is well known, that there is if a carbonyl group is there attached with CH3, this also will become into the CO. This is the one of the specific reaction. If keto is there, it oxidizes the side by this one into keto. If there is the alkene is there and allylic carbon is there, it gives a hydroxylation also. So these two reactions have no connection. Similar the way the selenium dioxide produces a triple bond into the dione. This is what its a reaction. In this reaction, that lithium aluminum hydride is well known. It converts into a glycol. A glycol is a sort of penacol, but if the two OHs are there, it would have become a penacol. So the answer A is a vicinal diol, that is 1,2 type of the diol. Penacol is also similar to that. Penacol will contain a diols with minimum 4 methyls. Okay, if one more ethyl is called a type of penacol. Oxyrane means it's a 3-membered ring, isn't it? Oxyrane. Oxetane means it's a 4-membered ring. In oxygen with 4-membered ring is oxetane. So these products are not formed. A vicinal diol is formed. Therefore, answer A will be the right answer. The question says that 100% pure isopropyl iodide can be obtained from the glycerol by the use of some of the reagents he gave. So isopropyl, that is glycerol, is nothing but a triol. 1, 2, 3 triol is the glycerol. They have the other hydrogens also, but when I treat it with the HI, so the iodide here replace all the OHs. It is works first as a iodinating agent. Then all the carbons will become the iodo. That is 1, 2, 3 triiodo compound will come. But we have one particular observation we might have seen in different cases. When I2 is added, it adds. But the diiodo compound is unstable, immediately elimination takes place and gives back the original one. Whereas the chlorination, bromination, these reactions are successful. 1, 2 diiodo compounds are unstable, it goes back. So here also there is a 1, 2 diiodo compounds. Therefore, what happens? 2 iodines will be eliminated. So what you will get is a allyl iodide comes. Okay, if only iodide, allyl iodide is wanted, you use just 3 moles of HI, you will get this product. But if excess HI is added, what happens? 1 HI will be added on this compound, following the Marconi-Cuff rule. The rule says that minus party will be added where hydrogens less and the H goes to terminal. So therefore, you will get a 1, 2 diiodo, the propane is formed. Again the same principle, 2 iodines are side by side, therefore elimination takes place and you will get a propene with the that is a allyl hydrogen containing propene is formed. Now once again you are adding the HI. When HI is added and the propene follows once again Markovnikov's rule. The rule says that minus parity H minus will be added where hydrogen is less. So finally what happens? 2-iodo-iodine will be formed. This will become the final answer. So that is a pure sample of isopropyl iodide can be obtained from the glycerol with excess of HI. Here actually 3 moles are consumed. Here 1 mole of HI. Here 1 mole. Total 5 moles of HI is consumed. However, twice you are removing the iodine also. So the reaction leads to give the isopropyl iodide. It's a wonderful reaction commonly asked in the different other examinations also. So the answer goes to the therefore B. B is the right answer. Denaturated alcohol is the alcohol which contains. Here the alcohol refers to the ethyl alcohol. Ethyl alcohol is the one which people drink for the as a liquor. In fact, so this liquor, when it is actually supplied to the different industrial companies and all that, but during that supplying it may be misused by the carrying owners and all that. Therefore, the alcohol will be small quantity of the some of this one of this product is added, so that it will become the smell of the alcohol is changed, and sometimes you may not recognize it is alcohol also by seeing the smell. So that is done by adding the small quantity of the pyridine. When pyridine is added, the alcohol will not be undergoing any change, but the smell and the taste of the alcohol is totally changed, and you may not easily readily distillable also. So such a type of the alcohol formed is called denaturated alcohol, that will be supplied to the different industries from where ethyl alcohol is produced, from where the medicinal industries and all that ethyl alcohol, when you are supplying a small quantity of ethyl alcohol will be, sometimes even sodium hydroxide is also added, but the best is the pyridine addition. So therefore question is here, pyridine addition makes denaturation. The answer goes to the C therefore. So let's go for the 16th question. The wood alcohol is, wood alcohol means many times most of the vegetables on distillation will give the ethyl alcohol, methyl alcohol. The methanol is called also spirit of methyl spirit, that is called. It in the many cases it is used in the medicine also, but the people drink ethyl alcohol, and to have a difference between this ethyl alcohol and the methanol, even sometimes ethyl alcohol is mixed with methanol in order to stop the drinking this ethyl alcohol or using the misuse this ethyl alcohol. But the methyl alcohol is prepared from the dry distillation of so many the wood and pyrolysis followed by the distillation will give the methanol. Ethyl alcohol is called from the fruit juices or from the sugar fermentation, molasses. In the preparation of the sugar you get molasses. Molasses contains the 10% ethyl alcohol, that is hydrolysis followed by the distillation will give the molasses gives the ethyl alcohol. But the wood alcohol is nothing but the methanol, ethanol and the propanol and the allyl alcohol. They are not called wood alcohols. They are called fruit alcohols or grape alcohols and so on. But the methanol is specially said as a wood alcohol. So the answer goes to the A. So let's go for the another question. Next question, 17th question. Which of the following is used in as a photographic developer? In the photography, once this silver bromide is treated with the light, it decomposes, and where the light falls and the negative and the positive picture is developed. After that, in the developing process, a paraquinol is used. A quinol is nothing but the reduced form of the benzoquinone. This is called the quinol. The quinol undergoes to become into quinone, and then in the photography reaction it is used. So paraquinol is the one which is used in as a photographic developer. So answer goes to the C therefore. Next question, that is 18th question. In the given reaction, the reaction is a carbon is there, a carbon with certain number of carbons followed by one more carbon, and then we have a hydroxy group. Here there is a bromine is there. The compound is treated with the sodium hydroxide aqueous. In actual what happens, it is a nucleophilic substitution reaction. If an alkyl halide is there, like a chloro or bromo and iodide, when reaction with aqueous NaOH, the NaOH happens to be the OH minus strong base and replace the Cl, you will get the COH. This is a standard reaction following nucleophile substituting, therefore you can claim it as a nucleophilic substitution reaction. So in this reaction also OH can come and replace to get what hydroxy compound, but this compound already is having one OH. Therefore, the OH coming and replacing this C and OH has got almost 1,000 times better chance, because its own compound attacking. Some other group coming attacking on the compound, it looks like in the reaction the OH can come from freely, but its own compound coming and attacking reaction. This is called intermolecular reaction. Always intermolecular reactions will be many times more. Many times it is said 10 to the power of 3 times, that means 1,000 times better chance will be there within the reaction. So therefore the OH attacking, instead of this OH attacking and replacing the Br, this OH itself attack and removes this one. So therefore you get a cyclo compound depending upon the how many carbons are there. Total 5 carbons are there, 1 oxygen is there. So totally you will get a 6-membered ring containing oxygen. It is called oxane. If the compound has 2 oxygens, dioxane, trioxane and so on, it is a cyclohexane. You too can number it also 1, 2, 3, 4, 5, 1,5-epoxy pentane. That may be systematic name. You may call it as a commonly oxane. This oxane is the answer. It is because of the what? A better facility for attacking intermolecular reaction rather than the intermolecular reaction. So leading to this, so answer D is the right answer. So let us go for the question 19. In the reaction given, it is a propyl and ethyl ether treated with the HCl and heated, X and Y is formed. It is a HCl heating. Actually HCl will not have much opening of this ether, but instead you can take a HBr, better one. Instead HBr you can take HI, that is much more better. Okay, ether will open, no doubt. Ether bond can be opened into the, if a HX is added, the one R will take up the O, becomes a H, another R will become into the R hex. This opening capacity is actually HCl will be the minimum. HCl will be the minimum, followed by the HBr. This is a better reagent. This is actually minimum actually. Better is the much more is HI. HI is the best excellent reagent that opens the bond and make into 1 into alcohol, 1 into the alkyl iodide. If both are similar, the question will not be there. Either one will take the alcohol, one will become alcohol, one will become. But if the question is like this, if one side is a tertiary one, if one side is a primary one, then which side should I break? If I break here, it will become plus, it will become minus. That is 3 degree carbocation, 1 degree carbanion. If I break here, 1 degree carbocation and 3 degree alkoxide formation, which is much destabilized. Okay, so therefore this has got a non-favorable, this is a favorable. So similar the way you two can also discuss in aromatic aliphatic also. If one side aromatic is there, one side aliphatic is there. If I cut here, you will get aromatic carbocation, where highly impossible aliphatic epoxide, that is also has got some minus point. Whereas if you break here, ethyl carbocation is the best stabilized by the inductive effect, and the hyperconjugation. This side what you will get a phenoxide with the benzene ring, like so the benzene shows a beautiful resonance and this ethoxy, the minus is given and the benzene goes like this, ortho para ortho negative charge. So this type of breakages will be very easy. Now here also in the question, if you see carefully, one side 3 carbons are given, one side 2 carbons are given. If I break here, you will get a carbocation which is supported by the 2 hyperconjugations and one the alkyl group. If I break here, you will get a carbocation which is supported by the 3 hyperconjugations and one alkyl group. Naturally, 3 hyperconjugations is more stable. Therefore, if I cut here, means carbocation will take the anion and the minus will take the H. So therefore, propanol, formation of propanol and the ethyl, the chloride will be the right answer. So therefore, such the answer here, the first option is the right answer. The second one is reverse is there, wrong. The third one is halogen and alkene. Alkene formation will not take place because we have not added here. And the other side, both alkenes are formed, that is also not possible. If the ether is very much heated with sulfuric acid at 170, probably the alkenes are strong bases are there, HCl would have been act as a elimination, but here it is a HCl we are adding and heating. So therefore, this type of the alkenes formation will not take place. The first answer is the right answer. Therefore, answer goes to the A. So let's go for the 20th question. In this question, a compound containing 2 OHs is treated with the side by side 2 OHs are there, treated with the acetone. Acetone is a carbonyl group containing the 2 methyls and then dry HCl is added in order to get a product. The product is asked here. In one case, the tertiary butyl group is added. Tertiary butyl contains 4 carbons and we have added only 3 carbons. How the 4 carbon come? That's wrong. The second option, there is a closure is shown. In the third option, Cls have come, that is HCl, Cls are coming. The OH may not be directly replaced by the Cl unless there is a reagent like concentrated HCl and the zinc chloride, that is called Lucas reagent. OHs may be replaced, that is wrong. So, and there is a ring closure here, it is a dehydrating agent. If you take, perhaps this may be, ring may be closed into epoxide. But what happens, best reaction is, the reaction is based on a wonderful concept here. Whenever the carbonyl compound is added with one alcohol splits into minus plus, and then this minus adds on the carbocation and the plus adds on the minus form. This is a standard reaction called what? Nucleophilic addition reaction. Nucleophilic addition reaction happens to be a standard reaction, that is characteristic action of the carbonyl compound. Then followed by what happens here, the OH is formed, OR is formed, this O takes H, OH is formed. This is called one side ether is formed, one side hydroxy group is formed. If one more alcohol is added, what happens? The alkoxy group replaces the OH. This is the nucleophilic substitution reaction. Then finally, 2 ORs are coming. This type of 2 ethers holding on the same carbon. 2 OHs, that means 2 ethers holding on the common carbon, is called acetal. First it was studied on acetaldehyde, therefore it is called acetal, and later it is called ketone is ketol and so on. This is called a one alcohol giving a ether and alcohol function is called hemiacetal. The whole reaction you may also show like this, a carbonyl group, if alcohol is given and another alcohol is given, a box may be shown like this and may be written as a CO and OC like this. If the alcohol is attached one, that is, if I take ethylene glycol, you will get a cyclic also. That is what here happened. What a alcohol is shown here, a carbonyl compound is shown here. These two will go out and a cyclic acetal is formed. Cyclic acetal is formed. acetone closes this glycol ring and forming a two ethers, and it is a cycle as well as acetal. Ethers are very much stable towards the dilute bases, strong bases, except the dilute acids. Even mild oxidizing agents also, they are not going to oxidize. Therefore, this is a quite a stable answer. So, therefore, answer goes to the, that is the ring fused one is B. B is the right answer. Let us go to the question number 21. He asked one particular compound how it is prepared. It can be prepared from the Williamson synthesis. It is a ether. The Williamson synthesis is a well-known reaction, won in Nobel Prize even. Williamson synthesis, you want to prepare a one side the tertiary butyl group, the other side is a methyl with a C6H5, a ring is also there. Doesn't matter, but the two different types of the groups are there. Now these two groups can be prepared basically from the two sides. One may be an alcohol. Better take a salt of alcohol and treat it with the benzyl halide. That is a benzyl halide. A benzyl halide, if you take this alkoxide will attack here and the reaction takes place. This is the one way of the reaction. The other way is you take the benzyl halide, benzyl alcohol as a compound CH2O minus, benzyl alcohol salt, and the tertiary compound as a alkyl halide. The theory says that the reaction, both the cases we have this is called actually substitution reaction, right? It may have another way also. Both the cases you may have other way also. This is the strong base, if it may undergo elimination, but in the elimination chance is almost nil. But if this is the base, this may undergo elimination also. This is substitution. That is a base. Alkoxides are bases. The alkoxide, if it attacks on this compound, it may undergo elimination. Elimination leads to give the alkene formation. Naturally, this ene is also large extent may be taking place. Therefore, in the scheme 2, we have a side product formation also. In the scheme 1, it is a only that ether formation will be the main reaction. Therefore, taking the sodium salt of alcohol and the benzyl chloride taking is the best reaction. Let us see the options here. First one is tertiary alkyl halide and the phenol of this one. This is what this first one he says, this is the A1 is this one, and the second one is taking the benzyl chloride. Benzyl chloride is taking and the tertiary salt as a sodium salt. This is the B option. So the B will be the excellent reaction because byproduct is nil here, because on this elimination you cannot take it. It's a 1 degree alkyl halide. Always prefer this substitution. So the elimination versus substitution, if the topic comes, it depends on the two criteria. One is stronger the base elimination, dilute the base substitution. Another point is based on the compound nature. If the alkyl halide is tertiary, elimination; if the alkyl halide is primary, substitution. So both the points here it is verified. It is a 1 degree alkyl halide and therefore the elimination it is not taking place. Substitution is the basis one. If a tertiary alkyl halide if you take, naturally elimination will be the byproduct. Huge amount of the elimination if it takes place, our substitution answer, main answer will be the becomes less. So therefore answer A, B will be the right answer. This type of the option will be the right. So answer B is the right. So let's go for the question number 22. He says an unknown compound X on treatment with the dichromate, that is oxidation reaction K2Cr2O7 in presence of acidic medium. It is an oxidation, he didn't mention, but let us take it as an oxidation reaction and gives another compound, unknown compound Y. Now he says which has only carbon, hydrogen, oxygen. This has got only carbon, hydrogen and oxygen. There is no other element like especially nitrogen, halogens are not there. However, that Y reacts with the iodine and the base like sodium carbonate. It reacts with iodine and sodium carbonate, Na2CO3. Boiling must be. It gives a well-known compound called CHI3. CHI3 is known as what? A iodoform. This is known as iodoform. Iodoform is formed from this compound Y. So therefore, what is this X? So that to get the iodoform, there are only two types of compounds are going to give. In the case of alcohols, the alcohols must have this type of function, then only you will get the iodoform. Or if it is a carbonyl compound, it must have this type of the function. This side you can have a hydrogen, you can have a alkyl group, you can have an aromatic group also. Here also the same, you can have hydrogen, you can have any alkyl group, you can have any aromatic group. But this particular function is described as what? 2 degree 2-hydroxy. 2 degree 2-hydroxy. This type is called a 2-keto. 2-keto. Except acetaldehyde. Here also, except ethyl alcohol, all 2 degree 2-hydroxy compounds will give. He says X on oxidation give Y. So that oxidized product cannot be an alcohol. This must be alcohol. This must be a carbonyl compound. So let us see the A. A is methanol, let us say. A methanol on oxidation gives formaldehyde, which will not give haloform reaction. An acetone on oxidation, again acetone gives haloform. But he says acetone on oxidation giving means it's not possible. Acetaldehyde also gives iodoform reaction. But he says on oxidation, acetaldehyde formed means this must be ethyl alcohol, which is not there. So therefore, the last answer is isopropyl alcohol. If X is isopropyl alcohol, yes. Okay. This also gives iodoform. But an oxidation gives a carbonyl compound, which is a acetone. The acetone gives haloform reaction, that is an iodination, you will get a triiodo and becomes into the iodoform, and plus this salt of the acetic acid is formed. So therefore, the X is asking, what is X is asking. If it, what is Y means it is a acetone, but what is X is asking, that is isopropyl alcohol. So therefore, answer goes to the, where is the isopropyl alcohol? That is D. So answer D is the right answer.